Yeah, we already discussed the difference between a normal C program and embedded C. I think the differences are clear. Okay, so at least you are clear. Okay, normal C program we are writing for the desktop applications, which you already done. That means you will be writing the program in the IDs or anything, even using some editors. Like if you are using the Linux platform, using Vim editor or VI editor or Nano. Okay, so using the editor we used to write the program, and using GCC compiler we used to compile, and we used to see the output. Okay, so that was we were doing in C program. Okay, but what we are doing in embedded C journey, I told already, the C program which we are like writing for a particular microcontroller. Okay, and that the microcontroller will be obeying you, and it will be doing some certain actions according to the program. Yeah, and embedded C will be an extension of the normal C language that help to develop embedded system. It helps to program a microcontroller based system. As I told already, we are going to use ARM Cortex controller in this course. Okay. And the C cross compilers, we will be using a term, or we'll be using something called cross compilers. What I mean by cross compilers, because we know, right, like when we are writing the embedded C program, always we used to try to write in our system. That means in the host machine, we used to write the program. So for example, if we are using x86 processor, okay, so that's a host machine processor, suppose. And if I would like to check the same project, like I did an LED blinking project or home automation project, which I already developed here in the host machine, if I would like to convert, or if I would like to transfer that to the target machine will be a controller, any controller, 8-bit or 16-bit or 32-bit, any microcontroller it can be. Then how we can actually run the same program which I tested in the host machine? How can I dump the same code, or how can I transfer this code to the target machine? So that is actually possible with the help of cross compilers. So cross compilers always will be creating the hex file, or creating the executable code, or the hex file, whatever it is. So that actually will be creating for the target machine itself. Okay, so there will be option to choose the microcontroller whatever we are going to use. Okay, so accordingly it will be creating, means it will be compiling, and it will be creating the machine code for you. And this machine code we can like directly dump into the microcontroller, whatever the hardware you are using. So be clear, we are using cross compilers here. Okay, why cross compilers? Because host machine and target machine will be entirely different. So if I am developing some project for the target machine, like I'll be compiling, I'll be writing the code in the host machine, then I'll be compiling that using the target machine. I think that's clear for all. And yeah, I think that is the basics of embedded C and how we are going to perform this embedded C programming. Okay, so I think many of you are having doubt. Okay, this kind of doubt you will be having if I'm actually creating a product. Okay, so that product is washing machine. How can I write the program inside the washing machine? We are not going to write the program like by connecting the washing machine. We'll be writing the program for the host machine, but we will be testing with all the peripherals like sensors, motors, everything. Like so many relays will be used over there. Okay, so relays for switching and all. Okay, because we are using like anything like motors and all, right, which will be working with 230 volts. So we'll be having relay circuit. So many things will be having behind the scene, but all will be tested like in the host machine with the system. And an embedded engineer finally using cross compiler, he will be making a machine code, and that machine code will be like actually maybe we are actually giving to the client, and they will do the production, and they will be dumping the same machine code in every product. It will be similar, of course. We can't actually like program each and every devices, right? Yeah, so that's one thing I would like to tell you about the cross compilers and how embedded C program is getting compiled. Now I would like to explain about the block diagram of embedded system. What do you mean by an embedded system? I think we have done enough explanation on that. Now I would like to show you the block diagram for embedded system. What are the different things involved in that? So you know microcontroller will be a tiny device. Maybe it can be the finger size, or it can be like smaller than that. Okay, so right now like advanced technology, that means advanced controllers will look like small. Okay, so they will be having different packaging, and the size will be small, but they will be having so many pins and so many features and all. Okay, so don't judge the controller by the size. Okay, the bigger controller will be better. It's actually a wrong myth, means a wrong idea. So inside the embedded system, you will be able to see there will be a processor. Okay, and there are some other peripherals like timer counter and program memory, parallel port, serial port, data memory, interrupt controller. We'll come to that one by one whenever we are doing projects. Okay, we'll be discussing about that. At least you can understand that inside even the microcontroller, there will be a processor which is actually helping, or which will be doing all the processes and all. Okay, and we'll be having an interrupt controller unit, so that will be controlling the interrupts. I'll come to that, what do you mean by interrupts and all. Maybe briefly, I would like to tell what is an interrupt. For suppose if I am actually watching a video on my phone, suddenly if I am getting a call, okay, so that call is something on urgent priority, right? Because the phone actually designed for voice calls, right? But later on we added so many other features and all. Even we are using phone for something else right now. But the actual purpose or the higher priority thing is the voice call. If I am getting the voice call which is on higher priority, the current task, whatever I am doing at present, so that will be stopped, and this task which is on higher priority, that will get executed. So this is actually known as interrupts. And even we should know how to handle the interrupts and how we will be able to handle the interrupts as per the priority. We'll come to that. Okay, one by one we'll be coming to that. And apart from that, we would like to discuss about the program memory and data memory. What is program memory? Where I'm storing the code, right? I told already, inside the microcontroller, we are going to store the software, whatever the embedded C code you have written. Maybe using cross compiler, you already created the machine code. So that the machine code I'll be storing inside the program memory. Okay, so program memory usually will be read-only memory because I don't want others to change or others to edit my code. So usually this program memory will be read-only memory. Okay, and we will be having a data memory. So data memory usually we used to say that as RAM, random access memory. So why data memory is required? Certain information I have to store, certain data I have to store. Even sometimes it will be like temporarily I would like to store some data. One example I would like to tell you. So for washing machine, okay, there can be a set RPM. For example, if I'm washing the clothes in like cotton, okay, if I'm selecting the cotton option, so they already set the temperature, like water temperature with anything. Like for example, the water temperature is 40 degree, so the RPM is 800, or some basic details, some basic data they would like to store, even like before. That means while manufacturing itself, they decided already. If the clothes is wool, so accordingly that set of data can be different. So this kind of data central will be stored in the data memory. As of now, just understand there will be a program memory which will be ROM, and there will be a data memory which can be RAM. And the processor, central one processor will be there that will be handling or that will be controlling all this peripheral communications and all these actions. Apart from that, we'll be having some parallel port control, serial port control. I'll come to that one by one. Serial communication protocol we will discuss. Okay. And timer and counter unit. This and like this diagram I'm showing a basic or maybe a simple microcontroller will be having at least these features. Okay. So as I told already, the advanced controller, they will be adding more features to that. That can be more complicated, right? And a power supply unit which is connected to the microcontroller, and other input and output devices and driver circuits and everything. Okay, so we will come to that different sensors we will try to discuss. So I told already input devices means sensors and buttons as of now, as per the example we are going to do. Output devices like LED, motors and anything. Okay.